Okay, so this chapter review is just designed so that you can listen to parts that you need to. If you are sure about parts, you don't have to listen to the whole thing. You can fast forward to the parts that you're confused about. But I wanted to make sure that we had a good understanding since this is kind of some new concepts and can be kind of tough. So let's go ahead and start with our first question. Okay, it says that theta is an acute angle of a right triangle. So what I would suggest first is just sketching a right triangle over here. Okay, so I have a right triangle, and either one of those acute angles could be theta. I'm going to go ahead and call that angle theta. And so I know that the cosine of theta, which is adjacent over hypotenuse, is 4 over 5, which means adjacent would be 4, hypotenuse would be 5. So in order to fill out the rest of these, the first thing that we are going to need to do is figure out what that third side is. Well, if I know two sides of the triangle, I can figure out the third side using the Pythagorean theorem. So just really quick here, I'm going to say I know that 4 squared, we can call that a, plus a squared equals 5 squared. So I have 16 plus a squared equals 25. If I subtract 16 from both sides, I get a squared is 9. And I take the square root, so I know that a equals, that my third side here is 3. So now I know all of the sides of my triangle, and I can go ahead and use my trig. I can use that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent to fill out the rest of these. Okay, well, I already know that my cosine is 4 over 5, so because that's given to me. Sine of angle theta is opposite over adjacent, which is going to be opposite is 3, adjacent is 5, or excuse me, hypotenuse is 5, and then the tangent of theta is opposite over adjacent, which is going to be 3 over 4. And then if you remember, each of these is just the cosecant, secant, and cotangent is just the reciprocals. So cosecant is going to be the reciprocal of sine, so that's going to be 5 over 3. Secant is going to be the reciprocal of cosine, so that's going to be 5 over 4. And cotangent is the reciprocal of tangent, so that's going to be 4 over 3. So you need to find all three sides and then use right triangle trig to figure out what all of those trig functions actually are. Okay, in the next section, we are going to find one positive and one negative angle that are coterminal. Remember to find angles that are coterminal. We just need to add 360 or subtract 360 until we get a positive or negative, whatever we're actually looking for. So if I have a 225-degree angle, to find a positive coterminal angle, I'm just going to add 360 degrees. And 225 plus 360 is 585. In order to find a negative coterminal angle here for 225, I'm going to subtract 360. And 225 minus 360 is negative 135. Okay, then you're just going to kind of do the same thing here. With number 3, 575, one way you could find a positive coterminal angle is to add 360 degrees, which if you add 360 degrees, you would be at 935. If you subtracted 360 degrees, you would still be at a positive coterminal angle, which is 215. So either one of those would be positive coterminal angles, because even when you subtract 360, you're still in the positive angle measures. So then we're going to have to subtract 360 again. So then we're going to take 215 minus 360, and we would get negative 145. Okay, these other ones here, you have negative 420. If I add 360 degrees to that, I get negative 60. That's not a positive coterminal angle because it's still negative. It is a negative coterminal angle, so we can say negative 60 is one. If I add 360 again, then I'm going to get 30 degrees, which would be a positive coterminal angle. If I had happened to subtract 360 from my very first one, negative 420 minus 360, I would be at negative I'd be at negative, maybe not, 780. So those are all possibilities. Negative 620, you would, if you added 360 degrees to that, right? So if you had negative 620 and you added 360, you're still at negative 260 degrees. That's still it's a coterminal angle, but it's still negative. So then I would need to add 360 degrees again to go around the circle one more time, and we'd be at 100 to get to a positive coterminal angle. If we had happened to subtract 360 in the very beginning, negative 620 minus 360 is going to get you negative 980. Okay, moving on to our next section. If we go degrees to radians, so this part over here on this side, degrees to radians, we are going to multiply by pi over 180. If we are going radians to degrees over here, we are going to multiply by 180 over pi. So if we do that, 200, zoom in here, 200 times pi over 180 is 200 pi over 180. However, we need to simplify that, and we do not simplify it with decimals or anything like that. It's not going to be a mixed number. We're going to leave it in terms of pi. 200 divided by 180 simplifies to 10 over 9, so we'd have 10 pi over 9. Negative 160 times pi over 180, we'd be at negative 160 pi over 180. Well, we would need to simplify that part right there, negative 160 over 180, which would be negative 8 pi over 9. Okay, going the other way here, we are going to go into degrees, so I'm going to take 3 pi over 10 and multiply it by 180 over pi. My pi's are going to simplify, so now I have 3 times 180 divided by 10, which is 54 degrees. Pi over 12 times 180 over pi. My pi's are going to cancel. 180 divided by 12 is 15 degrees. Okay, moving on here. Now we are going to just sketch these angles. And we have a negative 250 degree angle. Remember that if it is a negative, that means you are going clockwise. If it is positive, you are going counterclockwise. Okay, so negative 250, remember we always start on the x-axis. If we're going negative, we are going to be going clockwise, so I'm going to go 90, 180. If I go all the way up to here, that's going to be negative 270. I don't want to go to 270, I only want to go to 250, so I'm going to stop here. So I need to go an additional 70 degrees, which means this one would be 20 degrees. If I'm going 110 degrees, that's positive. That means I'm going to be going in the clockwise direction, or excuse me, counterclockwise direction. So here's where I'm starting. I'm going to go 90. Well, if I go all the way to the x-axis, I'm going to be at 180. I only want to go 110. So if I'm already at 90, I just need to go another 20 degrees. And then I'm at 110. Okay. So on this next one, 13 pi over 4. Okay. Probably the easiest way for most of you guys to do that is to think about, well, how much is 13 pi over 4 in degrees? Okay. You can use the unit circle to figure out where 13 pi over 4 would be. However, I think right now for most of you, easier would be to say, all right, how many degrees is that? Well, let's go ahead and change 13 pi over 4 into degrees. So I take it times 180 over pi. Again, my pi's are going to cross out here. And I'd take 13 times 180 divided by 4, which is a 585 degree angle. So I'm going to start here, and I'm going to go counterclockwise because it's a positive angle. If I go all the way around once, that's 3. I've already gone 360, so I'm going to subtract 360 from that, which leaves me with another 225 left to go, which means I need to go another 225 degrees. So now I go another 180. So if I go another 180, now I still have another 45 degrees I need to continue to go, which is going to stop here, and my reference angle here is 45 degrees. So if I'm going to sketch 13 pi over 4 in degrees, it might be a little bit easier for you than trying to figure it out in radians. All right, so now we have a little bit of right triangle trig. And again, just remembering that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In this one, I'm looking for a side length, so I'm going to find my angle is 30 degrees, x is opposite of it, and 18 is adjacent to it. So if I have opposite and adjacent, I am going to use tangent of my angle, which is 30, is x over 18. I just multiply 18 on both sides. And in my calculator, if I take 18 times the tangent of 30, I should get 10, approximately 10.4. Okay, that's when we're finding a side. This one over here, we are asked to find an angle measure, so I'm going to go ahead and call this x. Okay, and remember, when we are finding an angle measure, we are going to use the inverse, which basically is when we have to use that -1. So if I have my angle here is x, I know that 35 is adjacent to it, and that 46 is the hypotenuse. So if I have adjacent and hypotenuse, I'm going to use cosine, but since I'm finding the inverse, because I'm finding an angle, it's going to be inverse cosine of adjacent over hypotenuse. And we should get approximately 40.5 degrees. So there's some basic right triangle trig. Okay, now we have the law of sines and the law of cosines. So this is one that might take just a few minutes. The law of sines is usually a little bit easier than the law of cosines. So let's look at number 17. And remember, in order to use the law of sines, you need to have an angle and the side opposite of it. So if you're looking here, notice that in question number 17, I have that angle and that side across from it. Okay, which means I can find that side right there because I have, or excuse me, not that side. Sorry about that. That angle across from it. So let's go ahead and get that set up. So let's find angle B first. So I know that the sine of 80 over 100 equals the sine of B, which we don't know, over 61. Okay, if I multiply both sides by 61, I'm going to get that I multiply 61 times the sine of 80 divided by 100. That decimal value is approximately 0.5909 equals the sine of B. Okay, remember now I just need to go inverse sine because I'm finding that angle of 0.5909, and we should get that angle B is approximately 36.2 degrees. Okay, so we know, let's go back up here, what do we know? We don't know angle A, we know angle B is 36.2. We can easily find, this is 36.2. Now that we know that angle, we can easily find angle A because the triangles still have to add up to 180. So angle A is going to be 63.8 degrees, because they have to add up to 180. 63, there we go. Now in order to find side A, I can use the law of sines again. So let's go ahead and use that side and angle that we knew from the very beginning. We know that the sine of 80 over 100, those are nice easy round numbers to use, equals, well, we're finding A. So the sine of 63.8 over A. All right, so then we just do a little bit of algebra here. What we are actually doing, I'm going to cross multiply. That's how I like to think about it. I'm going to do a little cross multiplying. So I'd have A times the sine of 80 equals 100 times the sine of 63.8. Well, I don't want A times the sine of 80, so I need to divide out the sine of 80. And just be careful when you're putting this into your calculator. And you should get that A is approximately 91.1. And you should always go and make sure that, I kind of in my head, I thought, gosh, 91, that seems like a very long side. Is that messing up with an angle or something? But if you look at the lengths of the sides, this side is 100, this side is 61. So it seems fairly logical that that side could be 91.1. Okay, so this one is going to be a tad bit more difficult because it's three sides, which means you're going to have to use the law of cosines. And the one that I found first, I went ahead and found A first. Okay, so I found angle A. To do that, I need to just look up here at my formula. I'm going to use that top formula. Okay, and so I'm gonna actually just write the formula in here. I'm going to say A squared equals B squared plus C squared minus 2BC times the cosine of A. So let's fill in what we know. Well, if we look at our picture, this is A because it's across from angle A. This is B because it's across from angle B. And this is C because it's across from angle C. So A squared, I'm going to put the numbers in here, is going to be 12 squared equals 16 squared plus 18 squared minus 2 times 16 times 18 times the cosine of A. Be very careful, again, when you're doing these. You can add these together, but then you also need to multiply these before you subtract, or before you do anything else. So we would have, on this side, we'd have 144. If I add together 16 squared plus 18 squared, I get 580 minus 2 times 16 times 18 is 576 times the cosine of A. Now be very careful here. Do not try to put those together. Okay? Don't try to put the 580 and 576 together. That 576 is being multiplied by the cosine of A. So you need to actually subtract that 580 first, and you get negative 436 equals negative 576 times the cosine of A. I don't want 576 times the cosine of A, so I need to divide. Okay, so that decimal 436 divided by 576 is 0.7569 equals the cosine of A. So A, we're just going to put into our calculator, is the inverse cosine of that decimal. And angle A is 40.8 degrees. Okay, so now I can come back up here. I know that A is 40.8. Oops, daisies. Okay, and I can label that in here as well. And now that I know an angle and the side opposite of it, I know A and I know angle A, I can use the law of sines, which is way easier than the law of cosines. So now I'm going to go ahead and find angle B next. So I'm going to use my law of sines. I'm going to come up here, okay, and I'm going to say the sine of 40.8 over 12, because that's the side opposite of it, equals the sine of B over the side opposite, which is 16. So I'm going to go ahead and multiply by 16 on both sides. And when I take 16 times the sine of 40.8 divided by 12, I get 0.8712. Again, if I'm finding an angle, I'm going to use the inverse sine of 0.8712. And B is going to be 60.6 degrees. And once I know that angle B is 60.6, it's easy, triangle sum, to tell that angle C is going to be 78.6. Okay, so we've used the law of cosines here to find a angle measure. We've used law of sines to find sides and angles. So if you need any help with that, hopefully this has kind of helped you a little bit with how to do it. So our next section is going to be area and arc length of a sector. We have our formulas up here. That's something that you are going to need to remember for your test. And the other thing that you need to remember is that theta is the measure of the central angle in radians. So you just need to make sure that the first thing you do is change that degrees to radians of 240. So let's go ahead and do that. 240 times pi over 180. That's what theta is going to be. So theta is going to be, if we simplify that, 4 pi over 3. And once we know what theta is, plugging it into the formula is really not that bad. So area over here is going to be 1/2 r squared, well, r is 14, times theta, which is 4 pi over 3. And when you go ahead and put that into your calculator, you should end up with the area is approximately 410.3 centimeters squared. Okay, and then we have our arc length, that's S. So S, arc length, is just r times theta. And we know our radius is 14, and theta is 4 pi over 3. And when you multiply those together, you should end up with an arc length of 58.6 centimeters. Okay, coming down here, the unit circle, understanding how to use that. If you understand how to use the unit circle that is on the next page, this section is really not that difficult. What you should need to know and you need to remember, is that in order to find these values, you need to remember that the cosine of theta, the cosine of your angle, represents the x value of the ordered pair. The sine of your angle represents the y value of your ordered pair. And the tangent of your angle represents the ratio of y divided by x. So if we want to know 135 degrees, you go to your unit circle, which is on the next page, find 135 degrees, and the ordered pair is negative square root of 2 over 2, positive square root of 2 over 2. Okay, so finding these values is pretty simple. Sine is just the y value, which is going to be the square root of 2 over 2. Cosine is the x value, which is negative square root of 2 over 2. Tangent is y over x, which might seem a little bit intimidating to figure out since you have fractions and fractions, but you have the square root of 2 over 2 divided by negative square root of 2 over 2. And if you notice, it's the same thing in the top and the bottom. Square root of 2 over 2, negative square root of 2 over 2. Anything divided by itself is just 1, and we have that negative in there, which is negative 1. And then the cosecant, secant, and cotangent then are just the reciprocals of those. So I'm going to find the reciprocal. I'm going to have 2 over the square root of 2 negative 2 over the square root of 2, and negative 1 because the reciprocal of negative 1 is still just negative 1. And then if we come over here to pi over 3, go to your unit circle, find pi over 3, find that ordered pair that goes with it, and it should be 1/2 square root of 3 over 2. Remember, sine is y, cosine is x, tangent is y over x. So sine is y, that's just the square root of 3 over 2. Cosine is x, that's just 1/2. Hardest part is going to be dividing the square root of 3 over 2 divided by 1/2. Well, that's just the square root of 3 over 2 divided by 1/2, which is just the square root of 3 over 2 times 2 over 1. That's just multiplying by the reciprocal. The 2's are going to cancel, and you get the square root of 3. Now the second column is just the reciprocal of those. So you're going to have 2 over the square root of 3, 2 over 1, or just 2, and 1 over the square root of 3. Okay, very last thing here is, again, we're using the unit circle, okay, and we have the cosecant of 450 degrees. So where is 450 degrees going to be? Okay, well, 450 is going to be all the way around the circle once, okay, you're going to go all the way around the circle once, that's 360, and then another 90, so 450 degrees is going to be right here. So our ordered pair that we are using is 0, 1. Okay, cosecant. Well, cosecant isn't anywhere on here, right? Well, the cosecant, if you remember from the previous page, cosecant is the reciprocal of sine, okay? So that's just going to be 1 over sine, which is just going to be 1 over y. And in this case, the cosecant of 450 degrees, well, the sine represents the y value. Okay, well, the y value is 1, so you're going to have 1 over 1, which is just 1. The tangent of 3 pi over 2 okay, let's find 3 pi over 2 on our unit circle down here. 3 pi over 2 is right here. Our ordered pair is 0, negative 1. Okay, so the tangent is going to be y over x. Well, in this case, y is negative 1, x is 0. Well, you can't divide by 0, so if you are divided by 0, your answer is going to be undefined. Okay, just another example of one of these. Let's pretend we want to do the secant of pi. How about that? The secant of pi. All right, if we have the secant of pi, remember, what does secant represent? Secant is 1 over cosine. Okay, cosine, remember, in this case is just our x value. So it's going to be 1 over x. Well, if we are at pi, our ordered pair at pi is negative 1, 0. So if we are looking for the secant, that's going to be 1 over x, which is going to be 1 over negative 1, which is just -1. Okay, hopefully this review video has helped you a little bit. Go back and listen to any of the sections you need a little extra help with, and good luck on your test.